Hey guys, I'm going to be going over the 4.6 homework, and that's compositions. Alright, so it says for y equals f of x, so here we have f of x. Solve for y equals f of x for x. And so what that means is that, so let's say I take this function and I write it with y instead of f of x. Y is going to be equal to negative 7x minus 2. It's asking me to solve for x. So I'm going to solve for x. I'm going to add 2 to both sides. So I'm going to get y plus 2 is going to be equal to negative 7x. And then I'm going to divide by negative 7 on both sides. So then I'm going to get x is equal to y plus 2 over negative 7. Okay, so then it says find the inputs. So the input would mean x, and the output it's saying is negative 3. So find the input when the output is 3. So input generally refers to the x values, and output generally refers to the y values. And so when the output is negative 3, so x is going to be equal to negative 3 plus 2 over negative 7. So x is going to be equal to negative 1 over negative 7, which is equal to 1/7. So, yeah. Alright, same thing for 2 right here. We're going to write it as y equals negative 2 over 3x plus 1. And we're going to solve for x. I'm first going to subtract 1. So subtract 1, subtract 1. I'm going to get y minus 1. That's going to be equal to negative 2 over 3x. And then I'm going to multiply this by negative 3 over 2 and multiply this by negative 3 over 2. So the reason I'm doing that is because when these constants multiply, because they are reciprocals of each other, they will cancel. And so I'll get left with x. And then on this side right here, I'm going to distribute. So that's going to be negative 3 over 2y plus 3 over 2 when I multiply it with negative 1. And then same thing, we're gonna input negative 3 for y. So we get x is equal to negative 3 over 2 times by negative 3 plus 3 over 2. That's going to be equal to, when I multiply these together, I can multiply negative 3 and negative 3, so that's going to be positive 9. So 9/2 plus 3/2, which is going to be equal to 12/2, which is going to be equal to 6. Okay. Yeah, I think that's right. Okay. Same thing here. We're gonna write it as y equals 2x to the 4th minus 5. We're going to add 5 and add 5. So y plus 5 is going to be equal to 2x to the 4th. Going to divide by 2, so y plus 5 divided by 2 equals x to the 4th. And then we're going to 4th root both sides. So then we'll get x is equal to the 4th root of y plus 5 over 2. And we're going to input negative 3 for y, so we're going to get x is going to be equal to the 4th root of negative 3 plus 5 is going to be 2 over 2, and that's just going to be 1. So, alright, and last of all here, y is equal to x minus 5 to the 3rd minus 1. So we're going to add 1 and add 1. So we're going to get y plus 1 equals x minus 5 to the 3rd. And we're going to cube root both sides. So we're going to get the cube root of y plus 1. That's going to be equal to x minus 5. And then we're going to add 5 and add 5. So then I'll get x is equal to the cube root of y plus 1 and plus 5. So we're going to plug in -3, plug in -3 here. That's going to be, so we get x is equal to the cube root of -2 plus 5. 2 doesn't have a cube root, so we're just going to leave it like that. And I'm just going to leave my answer like that. I'm not going to worry about much else. So I think that should be fine. Okay. All right, so moving on from those type of problems, the reason that we have these type of problems is to kind of lead us into what inverses kind of are. And so if I were to take these formulas, so this formula right here, this formula right here, and let's see, where is it? So I'll say this formula, and then we say this formula, this one right here, and then this one right here. So if we take these formulas where we solved for x, if we at this point switch the y and the x in these right here, that's when we call them inverse functions. They're inverse depending on, I guess, the how you define inputs and outputs, but yeah. So find the inverse function here. So we're going to do the same kind of process that we did up in these problems, just when we get to this step right here, we're going to switch the x and the y, or you can even do that beforehand, so I'll show you what I mean. So we can say that y is equal to -3x. So what I'm going to do here is I'm going to switch the x and the y. So that's going to be x is equal to -3y, and then because I did the switching here, I'm going to solve for y, kind of like how I did in these problems where I solved for x. Here I left it as x, but then I could switch those right there and get the inverse. So instead of doing it at this point, I'm just going to switch the x and the y here, and then I'll solve for y. So then in that case right here, pretty easy step, I'm just going to divide by -3. So y is going to be equal to x divided by -3. And there I have this is called the inverse function. So this is the inverse of this function right here. I can make it look a little bit more familiar. I can write it as -1/3 times by x. These are equivalent statements. And so this is the inverse of this function right here. And so we're going to graph the function and its inverse. So let's go ahead and graph f of x right here. So we have -3x. So that's just a linear line with a slope of 3, and that has to be negative. So just like that. So that is our inverse function. Okay, and then what we're going to do is graph this one as well. I'll graph this one in green. Here we also start at the origin. It's linear, but this is -1/3, so that's going to be -1/3. And just like that. So now we have the inverse. Now, and something to note about inverse functions is that just like how we switched the x and the y here, the coordinate points are also switched. So you see here we have a point -1, +3. So if we go over 3 and -1, you can see that these are just opposite points, or switched points, you can say, I guess, like that. And then here, this one is -2 and 6. So if I go over 6 and -2, again, these are coordinate points that are just swapped. So all these points are just swapped, and that's what an inverse is. These lines right here are symmetrical about the line y equals x. So again, there's that relationship, y is equal to x. There's that relationship of them just being switched. There's a relationship of them just being mirrored across this line right here. And that's how you get and that's what inverse functions are. Okay? So let's try this one over here. So what I'm going to do is I'm going to write it with y equals to negative 2x plus 5. And then I'm going to switch the x and the y. So x is equal to negative 2y plus 5. And I'm going to solve for y. So I'll subtract the 5, subtract the 5. I'm going to write up here. So I'll get x minus 5 is equal to negative 2y. And then I'm going to divide by negative 2. I'm going to divide each term by negative 2, just so it looks in a more familiar format. So I'll get y is equal to, I'm going to write it as negative 1 over 2x, and then plus 5 over 2. So that will be a little bit more easier for me to graph, I guess, if it looks like that right there. But let's go ahead and graph the first function. So that's going to be negative 2x plus 5. We have a y-intercept of 5, and we have a negative slope of 2. Okay. Kind of again, just to reiterate, the inverse graph is going to have these points but in reverse. So even if you don't really know how to graph this one, you can kind of think about it like this. Well, let's say I take this point, which is the point negative 1, 7. So instead, I'm going to put x as 7 and y as negative 1. So I'm going to guess that we're going to have a point just like that right there. And then even this point over here, so this point over here is 6, negative 7. So I'm going to switch those to be negative 7 and 6 right there. So I think I should have a point right there. But let's go ahead and graph this graph right here to see what I get. So it says that I have an intercept at 2.5. So 2.5, which is going to be right here. And the funny thing is, this is at 0, 2.5. So if I switch those and do 2.50, you can see that I have a graph, or I have a point on the other graph right there. So again, just inverse. And then, so from here, we have a slope of negative 1/2. So that's up 1 and over 2. So that would be right here. Then we'll go up 1 and over 2. And then we're going to go up 1 and over 2. And then if I go up 1 and over 2, it'd be there. But I would cross right through that point right there, getting to that right there. So you can see that it does work out just like we planned it. And if we draw the line y equals x, you can see that we cross perfectly right there. That's because they are mirrored perfectly across the line y equals x. Okay. Got a couple more down here. So just know that this is y right here. So I'm gonna replace this as x and replace this as y. So I'm gonna call x is equal to 1 over 3y minus 1, and then I'm gonna solve for y. I'm gonna add 1, and I'm gonna multiply by 3. So that's going to become 3x plus 3 is going to be equal to y. So graphing f of x, to graph f of x, we have y-intercept at negative 1 and a slope of 1/3. Okay, just like that. And then if I'm going to graph the inverse function has a y-intercept at 3, and we have a slope of 3. Just like that. They do look mirrored, and then if you just draw the line y equals x, just like that, you can see how they perfectly intersect at that line, and they're mirrored across that line. So there you go. Okay. I'm going to switch x and y spots. Okay, just like that. You know what I'm going to do first? to get rid of these, since these both have a denominator of 3, I'm just going to multiply everything by 3. So that's going to become 3x equal to 2y minus 1. I'll add 1 over here. So I get 3x is equal to 2y. Oh wait, I'll get 3x plus 1 is equal to 2y. Then I'll divide everything by 2. So it's going to be 3 over 2x plus 1 over 2. So graphing the first function, we have a intercept of negative 1/3. That's kind of annoying. Negative 1/3, and we have a slope of 2 over 3. So up 2, and then over 3, and then up 2 and over 3, just like that, and then down 2 and over 3, down 2 and over 3. Whoops, I didn't go, so down 2 over 3, right there. Okay, so I think we have something that's going to look like that right there. And then as for the inverse function, we have a intercept at 1/2, and we have a slope of 3 over 2. So it's going to be up 3 over 2, and up 3 and over 2, down 3 and over 2, down 3 and over 2. Oop, I did something wrong. 1 second, let me redo this part. So we have a intercept at 1/2 and up 3. 1, 2, 1, 2, 3, and over 2, over 2. I am doing something wrong here, aren't I? I think it's with that first. What am I doing wrong? Rise is 3 and run is 2, right? Slope of 1/2. So if I go up 3, 1, 2, 3, 1, 2. Right? That's 1, that's 2, that's 3, that's 1, that's 2. 1, 2, 3, 1, 2. I think I was only going over 1 before. So 1, 2, 3 over 2. 1, 2, 3 and over 2. That lines up a lot better. 1, 2, 3, 1, 2. So 1, 2, 3, 1, 2. Please tell me this checks out. There we go. Okay. All right. Okay, good. Now we're getting into other things rather than just linear lines. So I'm going to switch x and y. Okay, here we say when x is less than 0, that will come up in a bit, but let me go ahead and solve for y. First I'm going to divide by 4, so I get x over 4 is equal to y squared, and then I'm going to take the square root. So I'm going to get y is going to be equal to the square root of x over 4. I'm going to say plus or minus because I did use a square root, and I'll explain why this right here is related to that right there. And so let's go ahead and graph the parent function first. So the parent function is 4x squared. So that's a parabola, so that's going to be, you remember the 1, 3, 5 rule, but we're multiplying by 4 because we have a stretch of 4. So that's going to be 4 and 12. It's going to be too far, but anyway, so go right there, go right there. So the parabola would look pretty narrow, and it's going to look like that right there. Now, here it says we're only graphing it when x is less than 0. So that's only this part right here. So I'm actually going to get rid of that and only graph this part right here. Okay? And then, let me go ahead and rewrite this as plus or minus the square root of x divided by 2. So that becomes a shrink if you think about it. That's plus or minus 1/2 square root of x. And we've learned how to graph square root of x, right? So square root of x looks like this right here. Or I guess you can say it looks like this. If it's negative, it's a reflection. But here's the thing. So we could graph plus or minus. So if we graph positive 1/2 square root of x, that's going to look like this. And if we graph negative, then it's going to look like this, and that's how we get those two branches, just like how this one had. Except this one, we said we're only going to graph for x is less than 0. So this one, we're going to graph when y is less than or equal to 0. So we're switching the x and the y here and graphing that, graphing accordingly. So when I say y is less than or equal to 0, we're actually only going to graph this part right here. Okay, now if you're not sure where to put the points, well, here's how you can get the points for this graph right here. All we need to do is reverse the points that we have here and draw it as we would. So we're going to have a point at the origin for this graph right here, square root of x. And then this point right here, which is -1, 4, I'm going to go over 4 and -1, and that's where the corresponding point is going to be. So this graph is going to look the same, just like that right there. And then if you think about oh man, right here. So this is the line y equals x. You can see how it's perfectly reflected across that line right there. Okay. For this one right here, so we have, I'm going to switch x and y. So this is going to be x is equal to y minus 3 cubed. I'm going to use the cube root on both sides, so that's going to be the cube root of x is equal to y minus 3, and then I'm going to add 3, so y is going to be equal to the cube root of x plus 3. Okay, and so that's what I'm going to graph. It's going to be up 3, and it's going to be the cube root function, so hopefully you guys remember how to graph the cube root function. So right here, the cube root function, well, I guess before we do the cube root function, let's go ahead and graph this function. This is the cubed function, and the cubed function, that's going to be moved to the right 3. So move to the right 3, and it's going to have points here and here, and then if you're going to think about perfect cubes. So 1 cubed is 1, -1 cubed is -1, 2 cubed, 2 units away, is going to be 8. And then -2, it's going to be right here. So 2 units away, it's going to be down there. So we get that, and we get this right here. As for this one right here, this is the cube root function, and the cube root function behaves very similarly, just this way, but it's going to be shifted up 3. And again, if you don't know how to plot the points, since I have this graph right here, I can just take the inverse points. So this is 3, 0, so 0, 3, I'm going to put a point there. And then just think accordingly, so we're going to do here, we're going to get it here, and then here, and then here. So we're graphing it this way. That's according to how we learned in 4.3 for graphing radical functions. But again, you can see that these are just inverse points reflected across the line y equals x. Okay, now that we're done with the graphing, we're going to do some. Alright, so determine whether the inverse of f is a function. Okay, yeah, so first of all, let's go ahead and let's find the inverse. So I'm going to switch x and y. That's going to be, oh wait a minute, do I need to do that? No, I don't. So just determine whether the inverse f is a function. So what I'm going to do, I'll show you how you can do this just through Desmos. Go ahead, we can go into Desmos, and we're just going to graph this function. So we'll go to Desmos. Maybe, yep, there we go. And we have -x³ plus 3. Okay, so here is that graph right there. Let me just for the sake, it'd be nice if you guys would just kind of show the general shape of the graph. So the general shape of the graph looks like this right here. Okay, So determine whether the inverse of f is a function. So this graph right here is a function. It passes what's called the vertical line test, meaning that it's only ever going to have one. Basically just means that for any input value, there's only going to be one output value. So that's what we mean by the vertical line test. Vertical line test shows that for this input value, I'm only going to have one output. For this input value, I'm only going to have one output. For this input value, I'm only going to have one output. So that's the vertical line test. So, but the vertical line test shows if this is a function. But what about the inverse of this graph? So because the inverse is a reflection over the line y equals x, if I do what's called the horizontal line test, so the horizontal line test, I can see that this graph passes a horizontal line test, meaning that for any output, there's only one input. So that means that whenever I do reflect this across the line y equals x, then that means the inverse function will pass the horizontal line test. So like for these graphs up here, for this graph right here, this graph right here passes what's called the, well, that's not a good example if I'm being honest. This one right here passes the vertical line test, which means that this is a function. And then if I use the horizontal line test here, it shows that it doesn't tell me that this is a function, it will tell me that the inverse is a function, and then I can even see the inverse right here. So if I apply the vertical line test here, it passes. But doing the horizontal line test here is the same thing as doing the vertical line test on its inverse. So that's the point of the horizontal line test. And so if this graph right here passes the horizontal line test, it means that the inverse of this graph is going to pass the vertical line test. So yes, the inverse is a function. Okay, let's go ahead and graph the next one, square root of x plus 4. So the square root of x plus 4. Okay, so let's go ahead. We're just going to show that that's what it's going to look like. Does it pass the horizontal line test? It does. So yes, the inverse is a function. Oh no, it says to find the inverse. Okay. I took up all the room to write that stuff. Alright, so to find the inverse, we're going to switch x and y. So that's going to be, x is going to be equal to negative y cubed plus 3. I'm going to subtract 3. I'm going to multiply by negative 1. So then I'm going to get y cubed is equal to negative x plus 3. And I'm going to take the cube root. So y is going to be the cube root of negative x plus 3. Okay, so that will be the inverse function. And it is going to be a function, okay? And then as for this one, we'll get x is equal to square root of y plus 4. So first we're going to square, and we'll get x squared is equal to y plus 4. Then we'll subtract 4. So we'll get, we'll get y is equal to x squared minus 4. But here's the thing, the domain of this function. So the domain of this function is that x has to be greater than or equal to negative 4, because that any number that's going to be less than negative 4 is going to make this negative, which we can't have square roots. So that means that this is only a function if we say, if we say that doesn't work, domain is x is equal to 4, but the range of this function is y. So this right here is going to be the square root function. It's going to be y is greater than or equal to 0. So I think I have to specify here that the domain for this one has to be in such a way that x is greater than or equal to 0, and the range is that y is greater than or equal to -4. So you see how I just switched the x and the y? So this will only be a function if this is true right here. You can tell that. So if I graph x squared plus or x squared minus 4, so x squared minus 4, that is not a function. Oh wait, no, it is. No, it's a function, yeah. Oh man, I'm getting twisted in my head. I was thinking if it was like that right there, that wouldn't be a function, but that's not what we have. We had, okay, no, we're good. We are good. The inverse of this, yes, it's going to be a function. Probably didn't need to write all that, but I was going down a rabbit hole in my head. Okay, let's go here. So for this one right here, 2x squared minus 5, let's graph that. So 2x squared minus 5. Okay, so we have a parabola. Let me go ahead and illustrate that this is a parabola. Now this one fails a horizontal line test. So no, the inverse is not a function. So the inverse is not a function. Okay. Then should I even bother? Sure. We can go ahead and switch x and y, so we get x is equal to 2y squared minus 5. So we'll add 5, so we'll get x plus 5 is equal to 2y squared. We'll divide by 2, so we get x plus 5 divided by 2 is equal to y squared, and take the square root, so we're going to get y is equal to, I'm going to say plus or minus, because I'm going to show to you that this is not a function together, the square root of x plus 5 over 2. So the square root, if I graph both the plus or minus, I'm going to get this function, but it's just going to be on its side. But that's basically two different functions. You can count it as two different functions, but together it's not a function, which is why you get that plus and minus. So, yeah. Okay. Okay, let's go ahead and graph this one right here. So 2x cubed minus 5. Okay, so it's just a cubic function. This passes the horizontal line test. So we'll say yes, inverse is a function. Okay, I'll be honest, I'll follow through with it. So we get x is equal to 2y cubed minus 5. We'll add 5, so we get x plus 5 is equal to 2y cubed. We'll divide by 2, so we're going to get x plus 5 divided by 2 is equal to y cubed, and take the cube root, so y is equal to the cube root of x plus 5 divided by 2. So this function will pass the vertical line test because this function passed the horizontal line test, making it a function. All right, here, so we got 3. So we got 3, and then we have the cube root of x plus 1. Raise that to the, 1 divided by 3. Okay, so that's what it looks like right there. So it looks like this. This is going to pass the horizontal line test. It's going to pass it, so we're going to be good right there. So yes, this is going to be, so yes, the inverse will be a function. I'm just going to write yes. And then to find the function, we have x is equal to 3 cube root of y plus 1. Or divide by 3, so x over 3 is equal to the cube root of y plus 1. We'll cube both sides, so we'll get y plus 1 is going to be equal to x over 3 cubed, and then we'll subtract 1, so y is going to be equal to, you can call that x to the third over 27 minus 1, and so that will be the function. Okay, and then we have -3. So -3, and then we have square root of 4x minus 7. 4x minus 7. And then we're going to divide that by 3. Okay, so it's going to look like that right there. So it's going to look like this. Okay, that just means that, so it passes the horizontal line test, so that's going to be yes. And so we get x is equal to -3 square root of 4y minus 7 over 3. So I'm going to multiply by I'm going to divide by -3. So I'll get x over -3. That's going to be equal to the square root of 4y minus 7 over 3. Square both sides, so I'm going to get x over -3 squared. That's going to be equal to 4y minus 7 over 3. We're going to multiply by 3, so we're going to get 3 times by x squared over 9 equal to 4y minus 7. You can reduce that to be 1 over 3, and then I'm also going to add 7. So this is going to be x squared over 3 plus 7 equal to 4y. Oh man, this is terrible. And then I'm going to divide everything by 4. So divide this by 4, divide this by 4. When I divide and divide, that's pretty much like multiplying the denominator there. So this is going to be x squared over 12, and then plus 7 over 4 is equal to y. Okay, that one was a bit nasty. Okay, last two problems. Determine whether functions are inverse functions using composition. So I'm going to use compositions, meaning f of g of x. This means this is a composition. It's like another operation, I guess you can say, but it's whenever you input another function into a function. And so we're going to show that f of g of x is equal to x, and we can also show that g of f of x is equal to x. So let's go ahead and prove that this is true for these, or if it's not true. So let's prove that these two are inverses of each other by using this proof right here. So f of g of x. So that means that this g of x is going to have to be inputted right there. So that's going to be 2, and then parentheses x over 2 plus 9, and then minus 9. Okay, there's quite the temptation for students at this point right here to combine like terms right there, but they cannot because of the fact that this is being multiplied by 2. You have to use your order of operations. So this 2 has to be distributed before it can combine any terms. So this is going to be equal to, when I multiply these together, that's just going to become x, and then that's going to become plus 18, and then minus 9. So that becomes x plus 9. So this did not simplify to be x. So I've already proven that f and g are not inverses of each other. Okay. Okay, as for 18, let's try this one. So we're going to do f of g of x. So we're going to input all of this right here in place of that x right there. So we're going to write 7, but now in place of x, I'm writing the function of g in its entirety in place of this x right here. All of that is being inputted for that x. I still have the 7, and then I still have to show the 3, I still have to show the 3 halves. Just like that. Okay? Whew. Yeah. Okay, and then I'll show the minus 4. So I still have the 7 here. I'm going to have the negative 4 here, the 3 halves here, but wait a minute. That's not to the 3f's power. I need to show that. No, it is. Yeah, no, it is, right? So I'm inputting all of this in for that right there. That is to the 3/2 power. Okay, now when I try to follow through with this right here, I can't cancel out the 7 because I need to follow the order of operations here. I can't subtract the 4's. Okay, and so what happens here, whenever I multiply these together though, they don't cancel out. So it's going to become x plus 4 over 7. That's going to be raised to the 9/4 power minus 4. Because these did not undo each other, I can't simplify anything here. I can't cancel out the 7's because this is being raised to the 9/4 power. I can't subtract those 4's together because, again, that's being raised to the 9/2 power. So, again, F and G are not inverses. Which makes me think, I'm wondering if I did this one right, one of these right, because I thought I put one in here that were inverse functions. So I input all of that in right there, alright? So I can't cancel out those 9's because that would have to, if I multiply the 2, that becomes 18. Okay, now if it were inverses, then everything would have worked out where they simplifies to be x, but okay, well that's everything for this homework assignment.